Good morning, students. My name is Dr. MPVV Bhaskar Rao, DSGT faculty. Okay. Now, I am going to explain how to solve recurrence relations by the method of generating functions. Okay. So, generating function is given by g of x equals to sigma n equals to 0 to infinity a n x power n. So in this display, L1 represents line 1, L2 represents line 2, and so on. Okay. So generating function is given by g of x equals to sigma n equals to 0 to infinity a n x power n. On expansion, it will be a naught plus a1x plus a2x square, a3x cube, and so on. Okay. Now let us take a problem. An plus 1 minus 8an plus 16an minus 1 is equals to 4n power n, where n greater than or equal to 1, a naught equals to 1, a1 equals to 8. Since it is the relation between general term and its preceding term, it can be called as a recurrence relation. Now we want to find the solution of recurrence relation by using generating function. Okay. So I have taken the recurrence relation, and both sides I have multiplied by x power n, and also I have taken a summation, that is sigma. Since n greater than or equal to 1, so n running from 1 to infinity, so I have taken the recurrence relation. Both sides I have multiplied by x power n, and also I have taken summation. Since n greater than or equal to 1, I have applied n from 1 to infinity. Okay. So now we are in line 7. Now, so an plus 1 has to be converted to an. For that, we need to replace n by n minus 1, and also in the third term, an minus 1 has to be converted to an. For that, we need to replace n by n plus 1. In the middle term, we already having an. So in the left hand side of the first term, we have replaced n by n minus 1 in order to get an. Middle term is as it is, and in the third term, in order to get an, we have replaced n by n plus 1. So we got line number 10. Okay. So from line number 10, the first term is rewritten as 1 by x into sigma n equals to 2 to infinity a n x power n. X power n minus 1 is written as x power n into x power minus 1. It is x power n by x. It is 1 by x of sigma. The middle term is copied as it is, and the third term, x power n plus 1, is written as x power n into x. X is taken outside since it is independent of n. And in the RHS, previously we have expanded sigma. We have expanded this sigma. It will be 4 power 1 x power 1, that is 4x. The other term will be 4 square x square, that is 4x square, 4x whole square, and so on. Okay. And this RHS can be written as 1 minus 4x whole power minus 1 with the help of the formula 1 minus x whole inverse. Okay. From 1 minus x whole inverse, 1 minus x whole inverse minus 1 will be x plus x square, and so on. Okay. Now we are in line 13. Okay. So from line 11, the first term is 1 by x into sigma n equals to 2 to infinity a n x power n. So it is running from 2 to infinity. In order to get gx, you need to add a naught and a1 x1. So this sigma will be equals to g of x minus a naught a1x minus 8 into. Here sigma is running from 1 to infinity, so we are missing the term with n equals to 0. Then this sigma is equals to g of x minus a naught, and in the line 11, the third term is sigma a n x power n, that is same as g of x. Okay. And a inverse can be written as 1 by a. Okay. Now we have taken, in line number 14, I have taken g of x common. So it will be 1 by x minus 8 minus plus 16, and I have the a naught value. A naught is 1, so it is minus 1 by x, and I have a1 value. A1 is 8, so it is minus 8, and x by x will be 1. And here also I have applied a naught as 1. It will be plus 8. In the RHS, I have taken the LCM, so it will be 1 minus 1 plus 4x by 1 minus 4x. Now I have simplified, and I got it in line number 17. It is g of x is equals to minus 4x square plus 4x minus 1 by 4x minus 1 whole cube. And I have taken the partial fractions. So for that, the partial fractions are a by 4x minus 1, b by 4x minus 1 whole square, c by 4x minus 1 whole cube. Okay. So I have taken LCM and I have simplified. So I have got line number 20. It is minus 4x square plus 4x minus 1 equals to a into 16x square plus 1 minus 8x plus b into 4x minus 1 plus c. Now I have compared coefficient of x square on both sides. So on the right hand side, coefficient of x square is 16a, and on the left hand side coefficient of x square is minus 4. On simplification, a equals to minus 1 by 4. Again, I have compared coefficient of x from line 20. I have compared coefficient of x on both sides. Okay. On right hand side, coefficient of x is minus 8a plus 4b. Okay. And on the left hand side, coefficient of x is 4. So on simplification and on substitution of value of a, I got b as 1 by 2. And again, I have compared from line 20. I have compared constant term on both sides. On right hand side, constant term is a minus b plus c. On left hand side, constant term is minus 1. On substitution, the values of a and b, I got c value as minus 1 by 4 from line number 26. So as we have taken partial fractions, I have substituted a value in line 27, that is a is minus 1 by 4, and b value it is 1 by 2, and c value minus 1 by 4. In line number 28, I have written g of x as sigma n equals to 0 to infinity a n x power n. Okay. And in line number 28, RHS, I have taken minus terms and I have simplified. Okay. Now, in line number 29, I have expanded the left hand side of sigma. It is a naught plus a1x and so on a n x power n. In the right hand side, I have written 1 by a as a inverse and 1 by a square as a power minus 2 and 1 by a cube as a power minus 3. Okay. And we use some formulas here. 1 minus x whole inverse is 1 plus x square and so on. And 1 minus x whole power minus 1 is, the formula is 1 plus, so this notation is nc1 x plus n plus 1 c2 x square and so on. And I have applied the formula from line number 29 to line number 32. LHS is same. In RHS, 1 minus 4x whole power minus 1 is expanded using 1 minus x whole inverse. It is 1 plus 4x whole square and so on. Then I have expanded 1 minus 4x whole power minus 2, 1 minus 4x whole power minus 2 using the formula 1 minus x whole power minus n. It will be 1 plus nc1x plus nc2x square and so on. And I have identified the general term n also. And I have expanded 1 minus 4x whole power minus 3 using the formula 1 minus x whole power minus n. So it will be 1 plus nc1, here n is 2, sorry, n is 3, 1 plus nc1, n is 3 into x, then n plus 1 c2, since n is 3, it will be 4 c2. Okay, I will modify here. Okay. And so on. And I have identified the general term also. It is n plus 1 cn 4x whole power n and so on. Okay. Then I have compared coefficient of x power n on both sides. In the left hand side, coefficient of x power n is an. In the right hand side, coefficient of x power n is, from the first term of RHS, it is 1 by 4 into 4 power n. And in the second term, that is from line 33, x power n coefficient is n plus 1 cn 4 power n. And in the third term of RHS, it is n plus 2 cn 4 power n. Hence, it is the solution of the recurrence relation.